Hey guys, it's Tiny Tom Logan back with another video for you, and we've finally got an ITX Ryzen board. So it's time to get tested. So a quick skim around the board just so that you can get a feel for the layout. Now we've got the 24 pin at the top, but then the 8 pin is kind of more inbound. Now a lot of the stuff is inboard, which may not be the greatest thing in the world when you compare it to an ATX motherboard, but it has to go somewhere. And when you think about having the 8 pin near where the power regs are, this is where the CPU power comes in, this is where the CPU power goes through into the CPU, it does kind of make sense. And you always do end up making some kind of sacrifices with an ITX board anyway. You've got some of the front panel headers around this area, but then you've also got a USB 3 at the top, your power connectors, your reset and all that sort of stuff for the front panel. So you've got some more stuff there. Really the biggest things to take out about it are we've got 4 SATAs, they're all vertical. You can get some fairly good, really thin cables actually, SATA cables. Silverstone do some really small ones. The blue ones are easily found, but if you're willing to put the effort in to have a look, then you can find the black ones. The M.2 is around the back, and you can see that we go up to 80mm for the M.2. So no 110mm support. There's no front M.2, so this is something you're going to have to consider if you're building a rig around it. You won't be able to get access this way. So you, one of the things I can say though is because of the way that the screws are, if you mount it in your case, then sometimes you might be able to cut a chunk out so that you can get access to, if you can get access to the back of your motherboard. Again, it's all going to come down to what case that you're using. It does have wireless and Bluetooth built in. You can see we've got a little vertical stand here, and you can see it all around the back. It's also got the onboard video ports for when so it supports the APUs properly, basically. See all the other connections there, including your Gigabit Ethernet. So there's it's a fairly well-spec'd board. The only thing that instantly is making me a little concerned is really when we turn it round this way, and I'll zoom you in, and that's really how small that VRM heatsink is. So you can see it's just spring clipped down, but it's literally the same height as your 8-pin power connector. Now I think they could have made it probably quite a bit higher if they'd wanted to for extra cooling. Now I get they're probably worried about people using specific coolers, but most coolers you could have got it in. They normally sit quite proud of the CPU itself. Any of the teeny tiny ones are likely to sit in this area anyway, and you can sometimes you can turn the coolers around so that they face away from this. So this is one of the things that we're a little bit concerned about, and it's going to take some investigation to if this cooler is actually big enough, because we can see that we've got 1, 2, 3, 4, 5, 6 power phases being cooled underneath that. And if you consider about some of the size of the heat sinks that you might have got on a 6-phase board with a full ATX case, then you can imagine that it would have been significantly taller and probably quite a bit wider as well. So we will have a look at that. The only other thing is if you have a look, you can see the teeny tiny chipset heatsink up in the top left hand corner. Fan connector, you've got one there, and I'm trying to find if there's another one. Yeah, there's another one down here. So this is your CPU fan, and then this is your system fan. So the other thing I would say when it comes to limited fan headers is I would suggest that you invest in some PWM splitters, and that's the best way to do it. Up to 3 is about fine, as long as you're not going to be running all 3 at 12 volts or maximum speed. If you do need more than that, then maybe think about a powered PWM hub where it's got like a SATA connector in it, and then it will feed all the fans extra power through that, so you won't be overloading the single onboard socket. Okie dokie then. So we've done things a little bit differently with this board, because normally what we would do is just chuck an 1800X in our boards and we would run through our batch of tests. But obviously this is a small board, it's got limited cooling and it's got limited power phases as well. So before we started the testing, we weren't even sure whether it would be able to cope with an 1800X. So what I did straight out the box is I dived in with a 1500X, a 1600X, and I run the 1800X as well. So a lot of people are going to ask about memory. So memory compatibility with the board, it's still kind of a bit hinky with AMD stuff, but most of the memory kits now are fairly good. Now you can look on the QVL list for stuff that you're going to be able to XMP, but even sometimes, even if it's not XMPing, you can go in and manually set them up and get stuff working okay. And I still say that a 3200 megahertz kit is there a good balance between the amount of money that you have to shell out, the performance that you're going to get from it, and also the amount of grief that you might get. Corsair LPX, they're all working fine. The G-Skill kits are all working fine as well. I have had Kingston working. One of the things with Kingston is one batch is one lot of ICs and another batch is something else, so they can be kind of a bit hit and miss. But it's 3200 megahertz as a ballpark figure is what I would say is a ceiling. But I have had 3333 megahertz running absolutely fine. In the BIOS, it does go up. You have got options up to 4000 megahertz, but they're not XMPing up that high yet, so I've not been able to get anything above 333 running on this board. Now I did say to you I run 3 CPUs, and all 3 CPUs did 3.9 gigahertz. 3.9 on the quad-core 1500X and the hex-core 1600X was actually the most that I got out of them from the X370 boards. With the 1800X, still got 3.9 gigahertz. Most boards were getting about 4 out of that. A really good board was getting 4.1 from it. So to be honest with you, with the fact that it's that much smaller, not got that many power phases, and still got 3.9, I would be absolutely ecstatic about that. And it does show the capabilities of the board. It does start to get a bit iffy though when we talk about voltage regulation, and the voltage regulation really isn't that good. Even at stock, I was getting the 1500X being fed with at points 1.48 volts, which is just ridiculous. It's way too high. Anything above 1.4 is a bit iffy, do you know what I mean? I can manually set these CPUs at 1.4 volts and get 3.9 out of them. They don't need to be fed all that extra amount. And the more you dig into the voltage regulation, the worse it gets, sadly, because if I go into the BIOS and manually set it to 1.4 volts on the V-Core, and then go into Windows, and I can set the 3.9 gigahertz as the overclock, so the core speed stays fixed and it doesn't move around, you then still can get peaks of 1.48, over 1.5 volts. So then I was like, give it a bit, you know, give it some fairness. Load line calibration was on auto. Then load line calibration is a bit of a minefield, because as you work through what it is, it goes standard, normal, low, medium, high, turbo, extreme. And the weird thing is if you do them in order, they don't literally make a great deal of difference. The lowest one is low, but you've got standard and normal before that, which was putting loads more volts through. So even at set to low with the 1500X, it would drop to 1.38 volts from 1.4, but then it would still peak up to 1.46. So there's too much of a gap between those two. And load line calibration, you want it to be a nice even voltage, not peaking around all over the place, because when they move around, that's more of an offset voltage, not a manually set voltage. So I know a lot of people are going to be going, I prefer offset, and that's cool. You can set offset. That's all available in the BIOS to be able to do. But it's kind of, the fact it's moving around too much is actually an indicator the BIOS isn't right, and it shouldn't be that way. So what I ended up having to do was, and this is something you can do at home if you've bought the board or you're going to buy the board, is what I ended up doing was putting 1.35 volts in the BIOS, because I knew the second that there was any load, it was going to boost it up anyway. So it was going from 1.35 up to 1.416. But it's that kind of level of, you know, we couldn't just get it to just run about 1.4. I mean, going down to about 1.395 and then going up to about 1.405 or 1.41, kind of, that would have been a, you know, a relatively you know, okay amount of movement. But the you know, right down and, you know, down to 1.38 and then up to 1.46 is just too much. And it didn't matter. I went through all of the different load line calibrations, tried to work it out. I turned all of the stuff off because it could actually be worse with some of the like cool and quiet stuff that was on. So I was turning all those things off, trying to get it to just do what it should have done. Now, what you need to realise is this isn't necessarily a Ryzen problem. This is a Gigabyte problem, because I've seen this exact same thing on the Z270 boards and boards previously, and it's something that I've just got bored of having to keep saying to them about now. They have to step up the quality control on the BIOS. Now, the other thing is, you'll be thinking to yourself, what BIOS were you running? Well, I was running the most recent retail BIOS. Now, so they have to start sorting these things out, because essentially what they're hoping is the people that are going to buy it aren't going to look. Now, that's not the way to go about it, is it? And I've got a lot more to say about this on the subject, but essentially the voltage control on this, the peaks, the load line calibration, the V-droop, it's not good enough. And it's all stuff that can and should be fixed in the BIOS. So when I bring this graph up, there's a few things that I need to clear up right from the start so that you're aware what's going on. If you look at the bottom of the graph, you can see that we've got downdraft high, downdraft low, and then tower. Well, the tower cooler was the Noctua U12S, which we run with the NFF12 that it came with, and we run that at 12 volts. Then I've also got, as fitted here at the moment, we've got the Noctua L12, which is their downdraft one, with the exact same fan taken from the tower cooler, which we also run at 12 volts, blowing down at the board, and that is our downdraft low, because it runs at about, I think it's 1500 RPM, 1200 RPM, but it's really quiet. Even though it's, you know, at 12 volts is quiet. But then the downdraft high, what I also did was grabbed a EK Vada, which is 2200 RPM. We run that at 12 volts for the downdraft high. And that is noisy, motor noise, but it provides a lot of cooling. So that gave us a few good options in between. I don't have a 2000 RPM Noctua server fan, otherwise I would have used that, just so that do you know what I mean, there was a bit of brand familiarity there. But this was something that I had to hand. I just chucked it on so that we would have the numbers. Now, the weird thing is I'm going to center the graph that you're going to see around VRM temps. So what you need to do is download hardware info, and then you look for VRM MOS, so it's VRM MOSFET, not the VRM SoC, because that's only one phase. So what you want is VRM MOS, and that's the temperature that you want to watch. And I used OCCT to do that. Now, to really stress it, and we did a 30-minute run with OCCT in Linpack mode. Now, one thing that you do need to be aware of is OCCT is a very stringent test, but it's actually probably not the worst. Prime would make this even worse. But what you can see in the graph when I bring it up is we've got a green line and a red line. And now the green line is the temperature that Gigabyte say is safe, and the red line is the one that I say is safe, and I'll explain the difference between the two. I emailed Gigabyte direct and I said, what temperature would you say is safe, and but a safe maximum for your VRM sensors? Now, what you need to remember is that the VRM thermal probe is between the VRMs on the motherboard, and none of the readings that you'll ever get are actually on the VRMs because they don't come with a thermal readout. So they said 70 degrees. Now, you can pretty much, you know, if it's on the motherboard, it's not going to be an exact temperature, and you might get sort of like somewhere between, you know, 5 and maybe like 20 degrees on top. but 20 degrees would be an absolute outside edge. I know with some other motherboard manufacturers, they say that the VRMs will be about 5 degrees difference, but we've actually got quite a small cooler on this, so we'll never know. So you're just going to know that it's a bit warmer. But the other thing that you need to think about is massive amounts of load that we're putting on with OCCT. That's kind of not normal use. So the 70 degrees that Gigabyte say under massive stress, I would personally say you can probably go to 90 degrees with that under this kind of stress, because then what you're then doing is, you know, that when you're using your rig and one of these motherboards is not really designed for running massive benchmarks. You're either going to have a small compact rig on your desk, which might not have a lot of airflow, or you're going to be running something small that you might have in your front room, like a streaming box or a small gaming PC or something like that. So they're normally going to be set up to be quiet. Now the other thing is, as you can see, we've got this on a test bench here. You've seen it in the other parts of the video, and the reason why we did that was because the differences between ITX cases can be kind of massive. They can be really, really tiny and really properly compact. Some of them haven't got much airflow. Some of them have, you know, they're never going to be the most performance-based kind of cases on the market, and there's quite a lot of differences. But one thing I can say is, normally when you put something like this in a case, you're going to end up getting slightly warmer temps. So this is actually quite a good scenario because it's fairly easily breathing. And I knew if I put it in a Corsair 540 Air, someone would say, what about the temperatures in this case? What about the temperatures in that case? And you can never really tell without actually building it and testing. And I've done enough testing with all the CPUs. I'm not going into it doing different cases as well. So the green line is what Gigabyte say is safe. I think that's, in fairness, I think that's a little bit too conservative, and I reckon you could probably go to 90 degrees with that, but only under OCCT stress. This is assuming that you're going to use your case for gaming duties and light kind of CPU stuff. If you're going to be doing video rendering or AVX sort of stuff, or really hardcore tests, I would say you want to stick to that Gigabyte 70 limit. So you've got that kind of, you know, mine kind of gaming, easy kind of use is 90. If you're going to go proper hardball, stay below that 20 degree limit. Okay, so that's the balance there. And you also know that we've tested 3 CPUs, stock and overclocked, on with 3 different cooling settings, and that's the graphs that we've got here. Actually took ages to test. But pretty much, if it goes beyond the green line, that's your Gigabyte, and you know that it hasn't passed that. And if it goes beyond the red line, you know it's not past mine. Now, one of the things that you can see here is pretty much without an absolute ragging fan at 2,200 RPM blowing down at the motherboard, that's the only way you can get an 1800X to pass with an overclock. I don't particularly see that as being a bad thing though. It's an 8-core processor in an ITX board with a tiny heatsink and with a lot of power being pulled. Although it's not the thirstiest CPU on the planet, it does still pull a fair amount of watts. So you've not got very many VRMs to be feeding it, so they are going to be getting warm. The worrying one though for me really is how close the 1500X at stock gets to the 70 degree limit with a tower cooler, because that tower cooler could be kind of linked to, it's going to be given the same amount of airflow as an AIO might. If you've got an AIO, do you know what I mean? It's not going to be blowing at the board, it's going to have the same kind of effect. And it's incredibly, incredibly close to that. And to the point where what I would personally say is, unless you're going to be undervolting or not putting a lot of stress on your system at all, I don't think that this board is really capable of running a tower cooler or an AIO, because it doesn't matter. With AIOs, you need to think about that's just cooling the radiator, it's away from the board's not really going to be getting any airflow, nothing direct. And if you're thinking to yourself, oh, I've got a case where I can set it to the top and I can bring the cold air in and blow it at the board, but once it's gone through your AIO, the air's going to get warmed up. And the further you move your fan away from the board, the less direct the temperatures get, and it actually does make a difference with temperatures as well. If you were to try it at home, have your fan directly on the MOSFET, and then as you gradually move it away, the MOSFET temps will go up. So with a cooler like this, it's fairly close. If you've got it at the top of your case, it's not really going to be doing as good a job. So these are all things that you need to keep in mind as well. So the board is capable of overclocking. The power regs are capable of feeding those overclocks as well. It's just that heatsink really isn't big enough. Now, this is an ITX board, but I think they could have made it bigger. And the thing is if what I think they probably should have done is just included a bigger one in the box that you could swap out. Because if you want that little bit more cooling, you put it in, because I know a bigger heatsink is going to be, it could interfere with coolers, and it depends what sort of setup that you're going to run. But if you've got it in the box, it's only going to cost a few dollars at the end of the day. It should have been in the box that people can swap, because as it stands at the moment, with that temperature that we got from the normal tower cooler, getting so close to what they say are their limits, and that was a question that I asked them, it gets to the point that it's within 1 degree, and I'm very, very specific about when I test in a 20 degree temperature controlled room, because that way when I talk about temperatures between different motherboards or even different platforms, what it means is that they're all comparable. And by them being all comparable, I can say, oh yeah, the Gigabyte Z270 board actually kept its VRMs at this, but this one didn't. It was, you know, a little bit warmer. They've all been tested in a very fair way. So if you were to have been running this in the random bit of English summer that we're getting at the moment, and the room might have been 25 degrees, that's going to have a direct impact on that number, and it's going to mean that it's going to go over that threshold. Or if you live in a hot country and you're not lucky enough to have air conditioning, or you may end up having it in your case that's set up to be perfectly silent because that's the way you want it to be able to run overnight, it's likely to tip over that point then if it starts to get insulated and run over a long period of time. So the long and short of it is, I think it did need a bigger heatsink, at least in the box. But also, I've looked around on the Gigabyte website because it's something that had been mentioned. They knew it needed airflow. It's not on the website anywhere that it needs airflow. And ITX boards, doesn't matter whether you're running them at stock or overclocking them, a lot of people build an ITX rig so it's quiet. And if you're running water cooling, for example, or an AIO, the reason why we do that is so, yes, it keeps our CPU temps down, but it keeps our CPU temps down, and then we have the fans running nice and low as well to keep it quiet. And the more you start to do that, the more those VRMs are going to warm up because there's no airflow. So you genuinely, I think, personally, no matter what CPU you're running, unless, like I said, you're going to be specifically undervolting your CPU and manually capping the volts, which I've already explained isn't necessarily that great, you're going to run into issues. And the other thing that I do need to make very, very clear is this isn't me banging on at a Ryzen, because it wouldn't matter whether this had a X299 socket on it or a Z270 socket on it. I'm just looking at the results. But I do need to say something very specific to Gigabyte, is that I realised very early on that this wasn't going to cut the mustard with the other CPUs, and especially once we introduced overclocks. So if you want to try and say to me, well, Tom, it's an ITX board, it's not designed for overclocks, why are the options in the BIOS for the starters? And secondly, if it's not really designed for overclocking, then why didn't you say that in any of the paperwork or anything on the website at all? Secondly, I not only didn't just do this, I could have just tested this and said it's not that great. I then went out of my way to add in 2 more tests with a different heatsink and 2 different fans to try and find out if it could be used. And it can. If you use the right kit, you can use this board, and let's face it, you can get away with an overclocked 1800X on this board if you use the right kit. So you can't come to me and go moaning about, do you know what I mean? Like, oh, he's just banging on Gigabyte. Well, no, I'm not. I've just tested it and I'm reporting the results. And the other thing is, which has really annoyed me lately, as it's been mentioned, why send it to him if you think he's going to find something wrong with it? Well, if you think he's going to find something wrong with it, don't sell it to the public, because that's the most critical thing here. I think this board needs to, you need to tell end users that they need to use a downdraft fan to keep those VRMs within a point that keeps them cool enough for your own standards. But the problem is your own shoddy BIOS is actually making matters worse, because those voltages are going up so high. Those VRMs are being worked harder than they need to be. So on a board this small, with a heatsink that small on the board, those voltages need to be so tight to help keep those temps down. And it's kind of making matters worse for itself. So we've got lots of points there that you need to think about. So heatsink, I would genuinely say Gigabyte need to change the heatsink on this and send out a bigger one, because there's the argument with the X299 boards that they're getting warm, but at least you can run them at stock and even overclock them depending on the benchmark that you use. Because with the X299 boards, OCCT isn't a problem, but Prime is. Issue that we've got is that OCCT is a problem with this. Prime is an even bigger problem, which is why I've been very clear about, if you're gaming and stuff, it's going to be all right. But, you know, we have to put numbers to numbers. So these are the things that you need to think about when you're going to have it. If you're thinking to yourself, well, I'm only going to game, is a tower cooler going to be enough? Probably not, because over a period of time, your graphics card is going to warm up. It's going to make the ambient in the case that bit warmer as well, so the VRMs are going to warm up. You do need, no matter whether you're running stock overclocked, airflow blowing over those VRMs because of that tiny heatsink. If Gigabyte make a bigger one that you can swap out, I think they should probably send that to everyone that's actually bought it at the moment. And the worst bit about it is, if you don't want to use a downdraft cooler and you've got an AIO or something like that and you're like, well, I don't know what to do about my board. If Gigabyte aren't willing to send a bigger heatsink out and you can't think of a way for you, especially with an AIO, the only way you're going to be able to do it is put fans on it, or someone make a teeny tiny water block for it, which then it's just, you run into horrific amounts of like ifs, ands, buts, hopes and all that sort of stuff. And you're like, I don't know what to do. I'd actually be saying to you, I hope you've not bought the rest of your kit yet, because I'd be wanting to send the board back. Because if you have to run an AIO, then you're going to have troubles. You really are, unless you're not putting hardly any stress on that CPU at all. And a lot of games can do now. Do you know what I mean? You might want to, you know, re-encode a 4K 10-bit video or something. That's going to smash those VRMs as well. So there's a lot of stuff there for you to think about. I know I'm not going to be popular with Gigabyte, but at the end of the day, if I'd have just done my normal review, we would have been saying bad things about it, and that wouldn't have actually have been fair, because we would have been saying, oh, you can only really use it in 1800X as stock. But even then, the 1800X at stock with a tower cooler was well out of spec for the temps anyway. So we would have been saying bad things, and I've gone to an extraordinary amount of effort testing all these different configs to try and find the stuff that it can do. But it all boils down to the fact that their BIOS isn't that great and that heatsink isn't really big enough for any use. So yeah, it's a bit of a weird one. If you buy it, buy a downdraft cooler. Downdraft coolers, I would advise, the Noctua L12 is brilliant and it's quiet. You've also got the CryoRig C1 that you will be able to use as well. Be Quiet do some as well, but you need to think about, they're going to be fairly big. I mean, the L12 here is about as level with a normal height graphics card. So it's going to depend on your case, but you need that airflow. And the more cores or the higher your overclock, the more airflow you're going to need. So I will leave that one with you. I'm going to wait for the butt mud flinging that's likely to happen when Gigabyte do catch hold of this. But it's just one of those times I've got to be fairly honest about it. And I have gone to those kind of lengths to show you, if you're willing to add the bit of noise in, then you can run big overclocks and stuff. If you want to drop the temps down a little bit more, you can test it at home. Hardware info, you can have a look to see what your temps are. Gigabyte say 70. I say as long as you're not running like big CPU stuff and gaming and stuff, if you keep it below 90 with OCCT, then when you do get into your gaming, it will be much below that, or you can just test it with just games. That would be a lot easier, wouldn't it? But each game is going to react differently with your CPU, so don't just think one game is going to be the same as all your other games. Try a run on each of your games for about an hour and see what your VRMs get to. So it may be something kind of interesting for you to kind of guys to try at home, but it's an expensive experiment if at the end of it it's making too much noise for you. But anyway, there's a bit of a bombshell for you there. I will leave you with that to digest as you should please. I'd love to hear your thoughts about the different take we took with this in the comments. But don't forget, we did it differently like this to actually show that it is good in some stuff. It's just the fact that we found out it needs a lot of airflow to keep stuff cool. Anyway, oh, the lights have changed now. In case you're wondering where I got this, Gigabyte sent it to me, and it's, if I unplug it, it's an RGB Aorus logo. And sadly, no, you can't buy them. They made them for shows, and mine got removed from a show stand. Anyway, right, I'm gone. You might be wondering about award. It didn't get one. It got the Kicking the Plums award. It got the Sad Cat award. It got the I'm Disappointed award. It got the Shouldn't Have Been Signed Off for the Public award. It got the Should Have Been Tested More award. It got the BIOS Needs to Be Better award. So yeah, lots of award. None of them are that good though.